finite measure, then convergence, almost everywhere convergence implies convergence in measure. Okay? Almost everywhere convergence implies convergence in measure. And probabilistic sense, it would be almost sure convergence implies convergence in probability. Okay? So that's the first part of it. The second part is, obviously you can ask about the converse actually. The converse is not true in general. So what is true is that, okay, if you have this convergence, then you can find a subsequence, okay, of this sequence which converges almost surely, not the original sequence. Okay? But what do you call? The assumptions are relaxed actually. If mu is a general measure, so it's a measure, not necessarily finite, then following is true. Then if Fn converges to F in measure, this is going to imply that there exists a subsequence F and K, okay, such that F and K converges to F almost everywhere. Okay, so the converse is not true in general, but true for a subsequence. This is what I would like to prove. So let's begin. So let's think about the second part. For the second part, what we have to show essentially that if a sequence is converging in measure, with some general measure, then I can find a subsequence which converges almost everything. Okay? This is what I would like to show. So suppose Fn converges to F, okay, in measure. Okay? Then, such a definition is true for every epsilon actually, no matter what epsilon we choose actually. Okay? Limit of that actually, limit of that. Okay, limit of that. Okay? So in other words, if I take, for example, if I take n1, here's the question. If I take n1 equal to 1, alright, then can I find n2? Then can I find n2, okay, which is strictly after n1, such that the measure, okay, measure of those points of x for which the distance between F, okay, and 2 minus F of x is bigger than 1 over 2, and this measure is less than or equal to 1 over 1 over 2. I'll generalize it afterwards, but this is what that I want. So can I have this? Think about it. So it just follows from the definition of convergence actually. So if the measure of such kind of set, so here is an epsilon, so like in general definition you have an arbitrary epsilon, okay? So I'm choosing epsilon to be 1/2 actually, okay? And I'm saying that, okay, can I make this epsilon, okay, arbitrarily small than 1/2? The answer is yes, I guess. The answer is yes. Why not? Okay. This follows by definition. And so what I want to say inductively, the answer is yes, of course. It follows from definition. Okay. So what I want to argue inductively that for each nj minus 1, I can find an nj after nj minus 1 such that if I take, the set of those elements for which fnj minus f of x, okay, is bigger than 1 over j, for example, okay, is less than 1 over 2 raised to j actually. I can make it arbitrary this one, I can. Things are in my control. Okay. Why this would be an interesting set now? This would be an interesting set. The measure of this. The measure of this is smaller than 1 over j. Let's give this set a name and call it aj. So aj is a collection of those points for which this is bigger than your chosen epsilon 1 over j actually. Okay? My claim is, take set, take what? Take the unions of such aj's where j starts from k to. So in other words, I'm trying to create an increasing sequence. So intersection of k equal to 1 to infinity, section of k equal to 1 to infinity of union of aj's, and give this guy a name A. What would be the interpretation of this set actually? What does this intersection and union is telling me? So what this means explicitly that I took first A1, okay, which I know is what. Then I'm taking A1 union A2, and then I'm taking A1 union A2 union A3, okay, and so on and so forth. So I'm getting an increasing sequence. And then I'm taking the intersection of this increasing sequence.
A1
It's not.
Yes.
It's not. And you have an infinite actually. You can't just straight away say that. Okay, yes, I have A1. Okay. It looks like you're gonna have something similar, but this is what. This is what. No.
The thing is.
Okay. So if I have A1. Okay. So then I have A2 union A3. Okay.
So A1 is up to infinite.
Okay. So it's A1 union A2 union A3 and so on and so forth.
And then again you have A2 starting.
And then you have A2. So it's other way around that.
Yes, sir.
Okay, A2 union A3 union A4 and so on and so forth. So it's a decreasing sequence. So it's a decreasing sequence, so kind of a contracting sequence, and so on and so forth. And then I'm taking the intersection.
What is that theory?
Okay. So you have got this, and then what would be the measure of A actually? 0. Okay, it would be 0, but how can it be? How can it be 0? So limit n goes to infinity, or maybe k goes to infinity. So this would be what actually? So if I give these guys name ck, for example, okay, so each such union I give it a name ck, then it's C1 intersection C2 intersection C3, and then C1 contains C2 contains C3 and so on and so forth. So this limit would be what? The mu of ck. That means that the measure K equal to
Sir, J is equals to K.
J equal to K to infinity of you know
AJ.
AJ.
AJ actually, yes. AJ. So this would be the case actually. Okay? And since mu is a measure, what does this tells us actually?
By summation,
Okay? So this will be less than or equal to limit K goes to infinity
summation.
of J equal to K to infinity of measure of AJ's. Okay? And what is measure of AJ?
It is bounded by 2 power, 1 by 2 power K.
So it's gonna be from each of the measure of AJ is less than sum J equal to K to infinity. Okay, because each of them is less than 1 over 2 to the J. So it's gonna be limit K goes to infinity of 1 over 2 to the J. And what would be this sum? Okay, this sum is whatever it's less than or equal to. Okay, what would be this? This is less than or equal to limit K goes to infinity of. Huh?
Geometry.
So it's a geometric sequence actually. So which sum is going to be bigger? This or if I start from 1 to infinity?
1 to infinity.
So this would be bigger than 1 to infinity. So in other words, if I take this from 1 to infinity, and what will be the sum from 1 to infinity?
2. 1 by 2 power J minus.
So this would be less than or equal to.
A will go to